Hi guys, in this video we're going to talk about how to solve a system of equations using the method elimination. Okay, this is different from substitution. This is another method of how to solve a system of equations. But before we do that, I do want to show you a quick review of a 2x2 system of equations that you did in Algebra 1. And then we'll get into the 3x3 here in Algebra 2. So here we have a 2x2. When you're doing the method of elimination, what you first want to look at is, do we have anything here, right, the x's or the y's, that are very, very similar? Can anything cancel out already, right? If we were to combine these two equations by adding them or by subtracting them, could you cancel the x's or the y's? And in this case, we can't eliminate anything just yet. Now, the good thing is that we can multiply the first equation times 2, and now it looks like 4. Or we can multiply this one times 3, and now they both have 3's. So this is a quick example of how you would know or identify whether you can eliminate a variable or not. The reason why we want to eliminate a variable is, right, because we cannot solve for x when there's two variables. So if we get rid of one, right, let's pretend that we're covering this, now we can solve a variable if we have just the y. So the reason why this is called elimination is because you're going to want to eliminate a variable so you can solve for the other one. Okay, so this is how we're going to approach it. We're going to get rid of x first. So I'm going to go ahead and multiply the first equation times 2. I'm going to multiply the entire equation times 2, and I'm going to rewrite my system. The thing is, I have to multiply everything times 2. Okay, so 2 times 2x is 4x. 2 times y is positive 2y. And 2 times 5 equals 10. All I did is I rewrote this first equation, and I multiplied everything times 2. I doubled the value of everything. And then I'm going to copy down the second equation right underneath it. 4x plus 3y equals 9. So now my purpose here, now that I have these two looking very similar, right, they're actually identical, now I'm going to want to be able to eliminate that variable. So what we're going to do is we're going to either add or subtract these two equations together to form just one equation. So we're going to go from two equations and two variables to one equation to one variable. So if we were to combine these two equations, what would cancel these 4 x's? Adding them or subtracting them? Since they're both positive, or since they're both the same sign, subtracting them is the way it's going to cancel the variable out. So I'm going to subtract the two equations together. And then I'm going to do my math vertically. Okay, I'm going to bring the numbers down. I'm going to combine the equations to just one equation. So 4x minus 4x cancels out to 0. 2 minus 3y is negative y. 10 minus 9 equals 1. So to solve for y, we want to divide by negative 1 on both sides. And we're left with y equals negative 1. Notice how we combine these two equations by subtracting, right? We combine these two equations by subtracting into just one equation. The x's disappeared. When we added these two, we got 1y. When we added these two, we got a number. So we're going to simplify this. This is called elimination. You're taking two equations and two variables, and you're eliminating half of the work. Half of the equation, half of the variables are going to disappear, right? The x's are going to disappear, and then the two equations turn into just one equation. So now it reduces down to one equation we can solve. Now that we have the value of y, we need to plug it back into either one of these two original equations and solve for x. So I'm going to plug in y into the first equation just because the first one looks like it's smaller numbers than the second one. You can plug this one into either one, it'll still work out. I'm going to use the first equation as an example. So I'm going to change the colors here. So I'm going to plug in the y in to 2x plus y equals 5. I'm using this equation to substitute. I'm going to take the y, plug it in, And then I solve for x. So I have 2x minus 1 equals 5. Move the 1 over. 2x equals 6. Divide both sides by 2. X equals 3. So now that I have my two solutions, I can rewrite this as a coordinate point, 3, comma, negative 1. If I wanted to check this, I could simply graph these two equations, right, on the calculator and see if that's the actual point of intersection. Okay, so hopefully this review of Algebra 1 helps you, right, as we progress to 3x3s here in the next problem. Things are going to get a little bit more complicated just because we're now involving three equations. But it's a similar idea, right? We're trying to combine these two equations into just one. And in the process of combining into just one, we want to eliminate one of the variables, right? Because by eliminating one of the variables, you can solve for the other one. And then once you have the answer, we can plug it back into the original two and solve the answer for the next variable. All right, we're going to take the same thought process and move on to the next one. So here we have a 3x3, okay? Now, the first thing that I'm going to do is I'm going to number these three equations. I'm going to number this as 1, 2, and 3, so that I know that when I'm talking about equation 1, equation 2, and equation 3, I'm referring to these in particular, okay? So, the first thing that I want to do is I want to look at the equations that look very similar. Equation 1 and equation 3 have similar x's. You see this x and this negative x? They're almost identical. So I'm actually going to use equation 1 and equation 3 as my first step to this problem. So let's do that. So here I'm going to put equation 1 and equation 3. That's my reference. Okay, so I'm going to rewrite those two. I'm going to ignore equation 2 for now, and I'm going to only work with equation 1 and equation 3 to cancel a variable. So I have negative x minus 5y minus 5z equals 2. And then the last step on the equation 3 is x plus 5y minus z equals negative 20. Okay, now remember, our purpose here is to cancel these x's. So since they're opposite signs, what do we need to do to these equations so that they can cancel each other? Do I subtract them or do I add them? Anytime that they're opposite signs, you're going to want to add, right? Because the negative plus the opposite, right, plus the additive reciprocal or the additive inverse is going to give you 0. So negative 1 plus 1 should cancel the 0. So I'm going to put a big plus sign here, and I'm going to do addition. I'm going to add these two equations together. Sometimes the equations you add, sometimes you subtract. It depends on whatever it is that you're solving that's going to help you cancel it. Okay, so by adding them, negative x plus x disappears. Negative 5y plus 5y also happens to disappear, and you're left with negative 5z plus negative z, which gives you negative 6z. And then 2 plus negative 20, right? Again, we're always looking at this plus sign for everything down the way. If we do subtraction, we're going to do subtraction for everything. In this case, we chose addition because that canceled it. So we have to continue doing addition for everything. That gives you negative 18. When you divide both sides by negative 6, you're left with z equals 3. And I was able to get one answer. Now, we used equation 1 and equation 3 to combine them. Now I'm going to use two other equations so that I can combine them as well. So I'm going to go with equation 2 and equation 3. It doesn't really matter which ones you go with, but I'm going to choose these two equations to combine. I can only combine two equations at once. Okay? I've already combined 1 and 3. Now I'm going to combine 2 and 3. You can always combine 1 and 2. It doesn't matter. As long as you do two equations and two equations, you should be able to combine them. I'm going to change colors so that it's not confusing. So I'm going to combine equation 2 and 3. So I have 4x minus 5y plus 4z equals 19. X plus 5y minus z equals negative 20. And again, I think, how can I combine or cancel some variables? Okay, now the thing is, here we were trying to eliminate the letter x. So whatever variable you eliminate in the first process, you have to do the same thing here. You have to eliminate the variable x. That is the goal. I know right now you can cancel the y's, but that's not what we did here. Our intention was to cancel the x's. So you have to commit to canceling the same variable for both equations every single time. Okay, so we're going to start by canceling these two out. And the first thing that you want to do is you want to make them look the same. So what do I need to multiply the bottom equation by so that we can get them both equal to the same number? We need to multiply the bottom one times a 4. So I'm going to go ahead and do that. I'm going to multiply the bottom equation times 4. I'm going to multiply everything here times 4. So when I do distributive property into everything, I'm going to rewrite this entire step, right? The first equation, I'm going to rewrite it as 4x minus 5y plus 4z equals 19. The second equation, right? I'm going to rewrite this thing down here. 4x, right? Because I'm multiplying everything as 4. 4 times x is 4x. 4 times 5 is 20. And 4 times negative z is negative 4z. 4 times negative 20 is negative 80. Now that I have the same x's, now I can cancel them. So, do we add these two equations or do we subtract them so that we can cancel the 4x? Well, since they're the same, 4x and 4x, we're going to subtract them to cancel them out. Right? Remember, it's either addition or subtraction. So here, since they're the same sign, 4 minus 4 will give you 0. So I'm going to subtract the two equations. In this previous problem, we added them because they were opposite signs, right? Negative x plus x cancels the 0. Here, subtracting them does the trick. So 4x minus 4x cancels the 0. Negative 5 minus 20y is going to give you negative 25y. 4z minus negative 4z, right? This minus negative changes to positive, so this really turns into 4z plus 4z, and that gives you 8z. And then lastly, 19 minus negative 80 turns into 19 plus 80, so that's 99. Okay, we were able to cancel one of the variables, right, in the process. Now, the thing here is that over here we were able to solve for z, but here we were able to solve for z. The good thing, right, is that we have the value of z, so I can actually substitute z into this equation and then we will be able to find y. And let's do that. I'm going to plug in, I'm going to do this in a different color. I'm going to substitute the z into this problem. So I have negative 25y plus 8z, which is 8 times 3, equals 99. And now I can solve for the letter y as well. So we have negative 25y plus 24 equals 99. We subtract 24 on both sides. We have negative 25y equals 99 minus 24 is going to be 75. To solve for this, I'm going to continue this process over here because I ran out of space. Negative 25y equals 75. I divide both sides by negative 25. So I have y equals -3. So I have z, I have y, now I'm just missing the value of x. So I'm going to go ahead and simplify, move this out of the way a little bit so that I can find the last answer. I have x, I have y, I have z, I just need the value of x. So at this point, you go to either one of the original equations, equation 1, equation 2, or equation 3 to find the last variable. Okay, I'm going to use this last equation because it looks pretty simple. Looks pretty small numbers in general, so I'm going to use that one to do it. Equation 3. So equation 3, let's change colors here. So plug in y and z into any equation. I'm going to use equation 3 in this case, okay? So I have x plus 5y, which is -3, minus z, which is +3, equals -20. So I have 5 times -3 is -15, so I have x minus 15 minus 3 equals -20. -15 minus 3 is x minus 18 equals -20. To solve for x, we move the 18 over. And we have x equals -2. I have my three solutions, x, y, and z. Sorry, my three answers for the values. So my one solution is going to be -2, -3, 3. Now, I know this was a very long process, right? This elimination method for 3 equations is pretty long. So let's recap a little bit. What we first wanted to do is we wanted to only worry about 2 equations at once. So we focused on equation 1 and equation 3. By doing that, we were trying to cancel one of the variables. We got lucky enough to cancel 2 variables, which gave us the letter z. Then, again, here we were trying to cancel the variable x. We have to do the same thing, cancel the variable x for any 2 other equations. So we chose equation 2 and equation 3. When we combined equation 2 and equation 3 to cancel for x, we needed to first make the x's look the same. So one of them was a 4x, so we had to multiply the second one times 4x. By doing that, we have a new set of equations. And then we said to cancel the x's out, we needed to subtract them. So we subtracted everything, and it gave us another equation. Remember, here in the blue section, we canceled for x, and the red section we canceled for x. This method only works if you cancel the same variable twice, using 2 different sets of equations. Then we were able to simplify it to 2 variables and use the answer from the previous one to solve for the last variable y. Once we have the 2 variables, right, we're going to use these 2 answers, plug it into any one of the original 3, and solve for the last variable. We ended up choosing equation 3, so we plugged it in for y and for z, and we solved for x, and that gave us our x, y, and z. Okay? The purpose of being able to do things in multiple steps or multiple methods, we've done substitution method and elimination method. So you can get some wiggle room and you get to decide which method is best for this situation. We have to do elimination for this problem because there's no short equation, right? For substitution, we're like, which one is the easiest equation to work with? And plug it in and solve for that one. But notice how 1, 2, and 3, these 3 equations, there's no easy equation. There's nothing short. They're all 3 variables long. So because we cannot solve for one variable as a first step, as we did in substitution, we are forced to do elimination. This is how you know that this kind of problem is elimination. Okay? Now, if you're dealing with a multiple choice problem, right, it might be faster to work backwards and plug in your answer choices in here to see if they are actually 2, 19, and -20. It might be easier or simpler to take A, B, C, and D and work backwards and to see which equation, which number, which set, or which solution would actually work for everything. But if you want to go about it, elimination this route, you can go about it as well. Please let me know if you guys need anything. If there's anything here along the way that confused you, just let me know what minute marker you needed more explanations, and I can add some stuff to the comments. I hope you guys are having a great day, and as always, I'll calculate later.